Hello and welcome to Trinomial Factoring Part 2. I wanted to show another example here of the same technique. So if you didn't see all the instructions for the first example, you might want to go back and look at the first video in the series. So as before, we have a trinomial that's given to us here, 3x squared plus 7x minus 6. We want to end up factoring it into two brackets that multiply to each other. So we're going to set up, as I said in the first video, the product and sum tree. In this case, my product is 3 times negative 6, which is negative 18. I'm going to take my middle number, which is the 7 here in the trinomial, and put it at the end of the product and sum tree. And now I need to find two numbers that multiply to negative 18 and add to positive 7. So if students are having trouble with this, they need to go through their times tables, multiplying things that multiply to 18. I usually get them to start with 1. 1 times 18 can get to negative 18 if one of them is negative, but you can't get a 7 by adding those two numbers. 2 times 9 would be the next two numbers that multiply to 18. We have to multiply to negative 18, so one of them has to be negative, but they also have to add to positive 7. Therefore, 9 and 2 will work if 9 is positive and if 2 is negative. And now we have those two numbers to help us do our self-check. Now, again, going back to FOIL, the first two numbers here have to multiply to the first term, 3x squared. There's only two numbers that multiply to 3. That would be 3 and 1. And because it's 3x squared, we also have to put our x and x in there. 3x times 1x would be 3x squared. And again, at this point, a lot of teachers would show that you would use trial and error to find the other two numbers, but with the product and sum tree, you don't have to. If we use the second part of FOIL, which is the outside multiplication, these two numbers have to multiply to one of these two numbers. And again, we're assuming that the 9 and the negative 2 in the product and sum tree have an x beside them because they came from the middle term of the trinomial. But we don't really need to know that because 3 multiplies to either 9 or negative 2. It can't be negative 2 because you need to use a decimal. It has to be positive 9. So 3 times what equals positive 9? It would be positive 3. And then we've got your 1x here, which is forming a part of the multiplication of the two inner terms of the FOIL acronym. So 1x times that number has to be one of those two numbers in the product and sum tree, but we've already used the 9. So the 9 can't be it. So it has to be the negative 2. 1x times negative 2 would give you, or 1 times negative 2 would give you negative 2. And as before, if you wanted to expand this using FOIL, you would see that you would get the trinomial above that. Now, one final example here, what happens if your first number in the trinomial has multiple factors to it? Well, let's start off and see what happens there. So the product and sum tree again, let's find our product. So 10 times negative 1 is negative 10. The middle number in this case is positive 3. That goes at the end of my product and sum tree. So I need two numbers that multiply to negative 10 and add to positive 3. The two numbers would be 5 and 2. In this case, the 5 would be positive, the 2 would be negative. And you have to check your signs when you're doing these. Sometimes both of them are positive, sometimes both of them are negative. It depends on what your product and sum tree is looking like. I've tried to stay consistent in these three examples so that you can see the technique done similar ways each time, but as you get more comfortable with this, you'll be able to work with whatever scenario shows up. So we've got our product and sum tree done. Now we have to look at our first multiplication in FOIL, which is the two first terms. But in this case, there are actually two different possibilities for our factors of 10. We have 1 and 10. But we also have 2 and 5. And depending on how big that first number is, this can get fairly complex. If it was a 24, there'd be multiple different versions of those factors. However, knowing the two numbers in the product and sum tree, I can eliminate the ones that don't work. I can't use 1 and 10 because there's no way that 10 can multiply to 5 or that 10 can multiply to negative 2. So right away, I can eliminate that scenario. So my two numbers have to be 2 and 5. Now I like to put the first number as the biggest number, so I'm going to do that here. So we would have 5x and 2x, which multiply to 10x squared in the trinomial. And once again, we would use our outside multiplication. Looking at the product and sum tree numbers, 5x times what equals 5 or negative 2. It's not going to be negative 2. 5 times 1 is 5, and it's a positive 1. And then we look at our inside multiplication. 2x times what is equal to one of the two product and sum tree numbers? Well, we've already used 5, so we can cross that one off. And it would have to be 2 times negative 1 is equal to negative 2 in the product and sum tree. And again, if you expand this, you will see that you will return to the trinomial you have. So this ends the tutorial on trinomial factoring.